Good morning. Laplace transform is a I am going to take the Laplace transform. It is a powerful mathematical tool with various applications such as physics, control theory, and then in signals and systems. It is a mathematical technique that transforms a function of time domain to frequency domain, and it analyzes the various linear differential equations and its behavior of time invariant systems. Before going to see the definition, conditions, and then the formulas, various formulas, we have to see where it's not applicable. Then Laplace transform is not applicable in some other places. The proper definition of Laplace transform is L of f of t equal to f of s, that is time domain into the frequency domain. The formula is integral 0 to infinity e power minus st f of t dt. Now the function in terms with respect to t. Now under which condition the Laplace transform exists? F of t, the function f of t should be continuous or piecewise continuous, and then f of t should be of exponential order. Now under these two cases the Laplace transform exists. If these conditions are not satisfied, then the Laplace transform is not satisfied. Now we are not able to find the Laplace transform for these two functions because of the existing condition is not satisfied. The first one is Laplace transform of e power t cube. This does not exist because it is not of exponential order. If you are substituting the conditions, you may not get the values. If you apply the formula L of integral L of e power t cube integral 0 to infinity e power t cube into f of t dt, so that exponential order is not exist. Similarly, cos t and tan t, the Laplace transform is not also exist because of it is not piecewise continuous. Now there are various formulas for Laplace transform. We'll see one by one. L of 1, the formula is 1 by s. L of t power n, n factorial by s power n plus 1. L of e power at, 1 by s minus a, e power minus at. If it is e power at, 1 by s minus a. If you have e power minus at, 1 by s plus a. Similarly, L of sin at, a by s square plus a square. Cos at, s by s square plus a square. Sin h at, a by s square plus a square. Then cos h at, s by s square plus a square. Now based on these formulas, we'll do some problems. The first problem is find the Laplace transform of t cube. Now we know the formula for L of t power n is equal to n factorial by s power n plus 1. Now in the place of n we have 3. So 3 factorial by s power 3 plus 1, which is 3 factorial is 6. So 3 factorial is 1 into 2 into 3, which is 6 by s power 4. So the time function is converted to the frequency domain here. Then L of e power 3t plus 5. You know very well the formula L of e power at equal to 1 by s minus a. But here we have L of 3 power 3t plus 5. So we have to write that term in terms of e power 3t into e power 5, because if the base is equal, we can add the powers. So e power 3t plus 5 will come. E power 5 is constant, that we can take it outside. L of e power 3t. Now L of t power at formula is 1 by s minus a. In the place of a we have 3, so 1 by s. So based on the formula, we will solve the differential equations. Consist of linear differential equations with some boundary conditions. Now for solving these differential equations, we need some derivative formulas. So that is L of y dash of t equal to s into L of y of t minus y of 0. L of y double dash of t equal to s square L of y of t minus s y of 0 minus y dash of 0. We'll apply this derivative formula for doing the problem. if there is any complicated problems that can be converted into the normal solving differential equations that can be solved by using Laplace transform. So the main applications of the Laplace transform is solving the differential equations. If there is any complicated problem that can be converted into an algebraic differential equation that can be solved by using Laplace and as well as inverse. Now, so what you have to write the differential equation is, so you write in terms of y double dash of t plus 2y dash of t plus 5y of t equals 0. Now some boundary conditions is given, y equal to 2, dy by dt equal to minus 4 until t equal to 0. So what's the meaning? We have y of t. This is the function we are going to find out finally. So at the time t equal to 0, the initial value y equal to 2 and then at the time t equals 0, y dash is minus 4. So these two values we are going to substitute in our problem. So that is the boundary conditions. Now you take first step is take the Laplace transform on both sides. After to eliminate this Laplace transform, you have to take inverse. So now Laplace transform of L of y double dash of t plus 2 into L of y dash of t. This 2 is constant. By applying the linearity property, we can take the 2 outside. So L of y dash of t plus again 5 is constant. L of y of t equal to right hand side L of 0. So we don't have any formula for L of 0. The transform is 0. So right side totally we have 0. Now apply L of y double dash of t formula. S square L of y of t minus s y of 0 minus y dash of 0. That you write it in the separate bracket. Then 2 times L of y dash of t. So that is s L of y of t minus y of 0. The last term plus 5 L of y of t. We can keep this L of y of t as it is. Now combine all the terms which consist of L of y of t. So we have 3 terms. The coefficient is s square plus 2s plus 5. So we'll combine that, we'll group it, then apply the boundary conditions. Y of 0, we have y of 0 equal to 2, y dash of 0 is equal to minus 4. So that two answers can be substituted here. Y of 0, 2 means minus 2s, y dash of 0 minus 4, already we have one minus, so plus 4. Then this term already grouped. The remaining term y of 0 is 2, so minus 2s. 2 into the value 2, 4. Right hand side we have 0. Then after that you keep L of y of t one side, the remaining on the other side. These 4 get cancelled. 2s divided by s square plus 2s plus 5. Now we want to find the value of y of t. That is, first you are taking Laplace transform. Now you want y of t answer. For that you apply inverse Laplace transform on both sides. Inverse Laplace transform. So by applying inverse, this L and L inverse get cancelled.